This is the second video on the notes on how to solve a quadratic equation by completing the square. As a reminder, you can use the left-hand column to write any questions that you might have throughout the video. So to get started, we're going to look at example 8 here. We have x squared plus 2x is equal to negative 5. So as you can recall from the first video, you want to get one side to be x squared plus bx equals something. So we've already have that set. Now it's always important to remind yourself that that number right there, the number in front of the x, that is your b. So to find the c, we're going to use b over 2 squared. So now we're going to replace that b with the 2 and square it, which is going to give us a 1. Now the reason why we did this is because the next step is to add the c value, which is the b over 2 squared, to both sides of the equation. So we're going to add 1 to both sides. And we now have x squared plus 2x plus 1 is equal to, and negative 5 plus 1 is going to be a negative 4. The next process, or the next part of the process to solve by completing the square, is to factor this perfect square trinomial. So when we factor this, we're going to get x plus 1 squared is equal to negative 4. So if you're looking at this thinking, my goodness, how did she get this so fast? You want to remember that this number here is always going to be b over 2. Since the original b value was this 2 here, I divide it in half, and that's going to give me the number I want when I'm factoring that perfect square trinomial every single time. So moving along, we're going to square root both sides. So we're going to have x plus 1 is equal to plus or minus, because whenever you square root both sides, it's always a plus or minus. Since we have the square root of a negative 4, well, the square root of 4 is a 2, but since it's a negative 4, we're going to write a 2i. And now we're going to solve the equation. So we have x plus 1 is equal to a positive 2i, and x plus 1 is equal to a negative 2i. So we're going to subtract 1 from both sides. So we have negative 1 minus 2i, and the other equation we have negative 1 minus 2i. Whoops, something went wrong. Oh, that one should be a plus. We're set now. And again, if you like the squiggly brackets, as I do, we're going to write the final answer in set notation. So we have negative 1 minus 2i and a negative 1 plus 2i as our two solutions. All right, so let's move on to example 9. We have x squared minus 11 is equal to negative 6x. So we need to make sure that we have everything with a variable on one side, everything without a variable on the other side. So that's going to be x squared plus 6x is equal to a positive 11. Now we need to add b over 2 squared to both sides. So over here on the side, I'm going to have c is equal to b over 2 squared. So our b value is this guy right here. That's 6. So we're going to have 6 over 2 squared. 6 over 2 is 3. 3 squared is a 9. So we're going to add 9 to both sides of our equation. So now we have x squared plus 6x plus 9 is equal to 20. Now we're going to factor this perfect square trinomial, and as I said before, the number that we have inside the parentheses is always going to be a b over 2. So I'm going to take this b over 2 and draw an arrow to this guy over here. So b over 2 in this instance is going to be a plus 3. Alright, so now we're ready to square root both sides, which I'm not going to draw in because my picture's looking a little messy now. So that's going to give us an x plus 3. And remember, whenever we square root both sides, it's always plus or minus the square root of that number. So from here, I'm actually going to simplify the radical because I do not like to see a number underneath the radical that is not simplified. So I'm going to cheat and I'm going to use the space over here just because that's where I need some space. So I'm going to break down the 20. That's going to give me a 4 and a 5. The 4 can be broken down into a 2 and a 2. So we have a single pair of numbers. So that pair is going to tell me to bring out that 1, 2. and the 5 is left over underneath the radical. So now we're going to solve this. So we're going to have x plus 3 is equal to a positive 2 radical 5. X plus 3 is equal to a negative 2 radical 5. So solving it, we're going to have x is equal to a negative 3 plus 2 radical 5. X is equal to a negative 3 minus a 2 radical 5. And if I had more room, I'd put the squiggly brackets in, but just for the sake of space, we're going to leave it at that. All right, so let's move on to example 10. Now we're all set up to add that c value, whatever that happens to be. So we're going to say c is equal to b over 2 squared. Now in this instance, the c is a negative 5. So we're going to have a negative 5 over 2 squared. So c is going to be, yikes, we're going to have a fraction here. So to square this, I'm going to square the number on top. So negative 5 squared is a positive 25. And I'm going to square also the number on the bottom. So 2 squared is going to be a 4. So I'm going to add 25 over 4 to both sides. Great. Alright, so what I have here now is x squared minus 5x plus 25 over 4, and I'm running out of room. There we go. Is equal to, and I actually want to get a common denominator. So 2 is equal to 8 over 4. So I'm going to add the 25 over 4, and that's going to give me a 33 over 4. So I'm just going to put it down as the improper fraction right now. So now we're moving on, and we're going to factor this perfect square trinomial. So when you do that, we're going to have x minus, and again remember, this number right here is always, always, always going to be b over 2. Well, our b over 2 in this instance is going to be a 5 halves, or a negative 5 halves as I should say. So we have x minus 5 halves squared is equal to 33 over 4. So now we're going to square root both sides. So we get x minus 5 halves is equal to plus or minus square root of 33 over 4. Now, I like to simplify the radical. I don't like having a fraction inside there. So if we did split it and we ended up having square root of the number on top and square root of the number on the bottom, well, the square root of 4 is just a 2. So I'm going to leave it like that. And so from here, I'm going to write my two equations. So I have x minus 5 halves is equal to radical 33 over 2. And x minus 5 halves is equal to radical 33 over 2. And I should say that's a negative radical 33 over 2. So the final answer will be 5 halves plus radical 33 over 2. And x is equal to 5 halves minus radical 33 over 2. And put a box around that, just to clean it up a little. Okay, so one example left. All right, hopefully you're looking at this example number 11 and you realize that x squared plus 14x plus 49 is already a perfect square trinomial. So I'm going to factor that already and just say that that's going to be x plus 7. Now I understand that you may not see it that quickly, and if you went through the process of subtracting the 49 and then adding b over 2 squared to both sides, you're going to come back and eventually get to the same spot anyway. So if you didn't see it, that's okay. Just follow the process that you feel comfortable following. So now I'm going to square root both sides. So I'm going to have x plus 7 is equal to plus or minus 8. Fancy that. We have just an 8 now. So now when I solve this, I'm going to get x plus 7 is equal to a positive 8, and x plus 7 is equal to a negative 8. So we're going to get two numbers for our answer. First is 1, and the second is a negative 15. Now, if you notice, this was the only example we have that has integer solutions. And the reason this one has integer solutions is that if we wanted to, we could have actually solved this equation by factoring. We didn't, but we could have done so if we wanted to. Now, keep in mind, I think this is actually really important to note. So you now are going to be completing your summary, and one piece that I think that is very valuable to include in your summary is recognizing when it's valuable to complete the square and when it's not. So if you were looking at these 4 examples, my guess is you looked at example 10 and you paused the video a couple times, or maybe you stopped halfway through, and the reason why this particular equation was not so much fun to solve is because there is a 5 there. That number is an odd number, and when you have an odd number there, it's going to give you fractions. So completing the square is definitely something that's more valuable if you have an even number in the B position. So that's something that I'm going to recommend that you add as part of your summary, which you should be completing right now.